tone.
Hello, everyone, and welcome to today's sponsored webcast, Cleaning Up Your Enterprise Data Architecture, How to Make Your Data Lake More Effective with an Operational Data Hub. My name is Mike Bailey. I'm with O'Reilly Media, and I'll be your facilitator for today's online training. Today's webcast is sponsored by MarkLogic, an operational and transactional enterprise NoSQL database platform that over 1,000 customers and 250 partners worldwide rely on to integrate their most critical data and build innovative applications on a 360-degree view of that data. MarkLogic is ideal for a wide variety of applications that involve heterogeneous data integration or content delivery at massive scale. They've become the world's best database for integrating data from silos because they actually make it easy to get data in and easy to get data out, while being 100% trusted to run critical business operations. In addition to providing great software, they also provide free training, consulting services, and 24/7 expert support. Headquartered in Silicon Valley, MarkLogic has offices throughout the US, Europe, Asia, and Australia. I'll turn the program over to our presenter, Damon Feldman, in just a moment, but first I'd like to go over a few housekeeping items to help you get the most from today's presentation. For you all to communicate and interact with, we have a group chat feature in the training platform, which is a brown icon located at the bottom of your screen in your widget tray. Please be sure not to post any personal information in the group chat because it will be viewable on our recording. Feel free to post your questions and comments at any time, and Damon will be addressing them. For today's class, please post any questions in the Q&A widget, also located at the bottom of your screen. Lastly, I want to let you know we are recording today's presentation and we'll have it ready within 24 to 48 hours. We'll notify you with an email as soon as it's ready for viewing. At this time, I would like to turn the program over to Damon Feldman, Solutions Director at MarkLogic. Hello, Damon.
Hi, Mike. Thanks for the intro. Well, with that, I'll just jump right in. Welcome, everybody. I'm going to talk, as Mike said, about data lakes and an extension to that pattern, which we call a data hub pattern, of how to get the value out and organize and clarify that data. My name's Damon Feldman. I work at MarkLogic and have for quite a long time. I'm on the delivery side, so I work with our customers as they're really trying to get the work done. And I have for a long time, almost 10 years now. So I'll bring that experience and some of those use cases to this talk, and we can talk about how it really gets done. So with that, what's the situation with lakes, right? People often call a lake as having a risk of drifting into a data swamp, and that's certainly true, and it's something I'm going to talk about. But I don't want to lose sight of the fact that fundamentally, data lakes are great technology. They are in some ways revolutionary, right? Because you can take any data from any source, move it into this low-cost array of cheap disks. You don't have to have a really expensive SAN. And at least gather and put your data in one place to have access to it. The thing that's missing from that is once it gets there, how do you get it back out? What do you do with it? And at a business level, at a high level, how do you get the value out of the lake once it's put in there? And I'm going to talk a lot about these phrases here: indexing, security, and governance. So the metaphor is to clean that up in some way, maybe not all of it, but enough that it's got the critical assets, and put it into a data hub, which I'm representing in this image, where we've not only put it in one place like a hub, but also as these little sections illustrate, we sort of organize it by the business domain and by the business entity so that it's usable in a more standardized way. So by the numbers, there's no official definition of a data lake. I'll preface this by saying a data lake is a pattern, but it's become almost synonymous or very closely associated with Hadoop. And this definition from James Serra is the data lake is a repository, usually in Hadoop, that holds a vast amount of raw data in its native format until needed. So that's the first thing, just to move it and hold it and have it in one place. And then the typical use is it's a great place for investigating, exploring, and experimenting. That's ad hoc exploration, data science, data analytics, in addition to refining and archiving. And the refining, to my mind, what James is probably talking about, is that a lot of the ETL that used to be done with bespoke technologies and point-to-point connections, a lot of that ETL is now done inside the lake. It's not fundamentally different, but it's been relocated. So as I said, a data lake is an architectural pattern associated with Hadoop. I'm going to focus on these words that we see on the page here. The focus is on movement. So that's one of the 4 critical things. The other 3 critical things, though, we need to add, and that's indexing, harmonization, and security in order to have better access, standard access, and secure access to that data. So just a historical note about Hadoop. As many of you may know, Google originally published a paper called about the MapReduce algorithm. And they were using that algorithm internally to do their web page indexing, to do really the core business of Google, run huge batch jobs, and organize web pages according to what kind of content is in them. They actually abandoned that. It didn't work out for them all that well. But somebody read that paper, a couple people, one at Yahoo and one at a university, I forget, Doug Cutting, someone else, and they wrote the initial Hadoop system called Nutch, and it became Hadoop. Its real goal was to do massive, typically 24-hour or overnight batch processes that were so large, involving so many machines, that a lot of those machines are likely to go down during the batch process. You don't want to rerun the entire process. So it's got a self-healing break up and rejoin quality to it, where if any little chunk fails, you just rerun the one chunk. The key thing there that I think people don't appreciate when they start out with Hadoop is that Hadoop is batch in its soul. It just wants to run massive heavyweight batch jobs, and there's a lot of great things you can do with that, but other things not so much. So you got to understand what it is and where the value is. One of the core values down here under many components, cheap redundant disk in the HDFS. Used to be you couldn't get a lot of disk unless you purchased an expensive SAN. With such a rapid move to the cloud, that's not as true anymore, but there is a lot of value in this cheap disk, and there's a lot of tools. Pig, Hive, Squoo, Spark, all kinds of Zookeeper, all kinds of things are in the ecosystem that are a rich set of tools. So the good and the bad and the ugly of that, both the good and the bad, and I'll hit the next button here, is that they're very flexible and you have unrestricted access. So that flexibility, to my mind, I draw the analogy to HTML. Anybody can throw up an HTML page and kind of make it work. And for those of us old enough to remember when it happened, web pages exploded in the 90s and really just took over the world. It's because anybody could do it. You didn't really have to be a computer programmer or really skilled because they're so forgiving. Hadoop and HDFS are like that. You can put anything anywhere. You can put a file name on it, and here's this horrible file name, churn analysis, customer data, partial dedupe, algorithm 4, June 22nd, Bob. You can kind of tell somebody really wants to track a little metadata about this file. All they had to do to make that happen was to put it into the name of the Parquet split. And you can end up with a lot of junk like that, right? So that's sort of the ugly of here's a slide from the good, the bad, and the ugly of these data lakes. And what's missing is trust. If you don't know what phases the data went from, you don't know when it was taken in, this could be an accurate customer data file with a good algorithm, but from what month, right? When you don't know all that, it's hard to rely on the data. Just as a similar example, I had that problem when I was trying to do this slide. I couldn't find these slides. It was here on my file system in one of these folders. I eventually found it down here. And Hadoop's the same way. We all know this problem. It's hard to organize and keep track and govern data, know where it is, know when it got there, know why it's there. So what's the data hub pattern, right? Data lakes are implemented a lot with Hadoop, but it's really a pattern that could be done on a regular file system or a NoSQL database. What's the pattern extension that I'm going to talk about today? It's mostly this hub pattern. And it's similar in some ways. We also sorry, I'm taking a look at my slides here. We're using a new tool. We're also looking at all the data as is and being able to move it all into one place and just have it. And I want to emphasize how important that is. If I have some mortgage application system that's running all day long, and I need to pull 50 gigabytes of data out of that in a batch process, I have to coordinate that and find a batch window when I'm allowed to do that and ask for permission from the data owners. But once I've gotten that extract going, I'm putting it in my data lake or my data hub. Now I have free unfettered access. That's a big deal. But these other terms that I'm focusing on are also here. We want to add this indexing the data and also a concept of progressive transformation. Bring it into some kind of a core model, not by building a giant enterprise data model with 50,000 fields or even 1,000 fields, but case by case, use by use, start to build up an inventory of useful models and transform all of this disparate data into it, right? Get the silos into one format. And then finally expose it via APIs. APIs is not something we think of a lot with data lakes, but it's one of the missing ingredients, I would say. By not having an API layer on top of our data lakes, there's a lot of fragility. People build something that depends on a certain file format in the Hadoop data lake, and then when you need to update your processes in the data lake, you break the downstream consumers. So you need another layer of indirection in the middle to broker that communication and have a clear contract between the consumers of the data lake and the data lake itself. And that's added by this hub process. So this handles the movement in the data hub, but we're adding indexing, harmonizing the data, again, in an agile, progressive way, not a big bang way that's almost impossible to do on time. Some controls over the data, especially control over how it's released through APIs, and a big deal, you really want to layer security on top of the data lake. The data lake, to the extent that it becomes valuable and useful to you, it's also a valuable target for an internal or an external attacker who wants to steal or have unauthorized access to the data. And the more successful the data lake is, the more you need to layer security on top of it. There is some security, by the way, in the Hadoop ecosystem, but it's extremely fragmented. I want to say there's about 70 or 80 main Hadoop tool sets out there, and maybe a dozen of them have some kind of security, and most of that security is fragmented where you have to implement it separately on all 12 components. Here's a quote from a colleague that I work for in another organization called RandomBit, Gerhard Ungerer, and he says that remedying the data swamp and making it available and these are these key phrases, a consistent, indexed, searchable, and secure way, right, that adds the value, requires the flexibility of Hadoop with the enterprise capability of something you find in a database. So Hadoop's great, very flexible, but we want to add these capabilities. Okay, well here's the pattern that I'm going to talk to you about. It's a little bit of a complicated slide here. It's a lot on it, but it's really only got 3 or 4 phases. On the left, we have the ingest and discover phase where we pull it in and we manage the raw data. Hadoop and traditional data lakes are actually pretty good at that. Then the middle phase is modeling and harmonizing the data to get it into the harmonized data form. And then the last couple things on the right are privileges and permissions. That means security, securing the data and delivering the data in various ways. So this is a little bit more detailed, showing the consumers and producers of that data, but that's the same pattern. So the first thing we want to do is bring it in and also index it. So that means indexing relational files and CSV to say it's not just a flat CSV file, but we understand what's in every column, pulling in message formats like JSON REST requests and XML requests from SOAP, indexing those, looking at data standards, typically XML, whether that's HL7 or FixML or anything else. We also then want to do useful things with it, check its quality, put it into a common format, transform it, As we get different things from different places, we almost always have overlaps between records from different sources. To have half of the picture, we have to master and join that data together into overall business entities. Keep track of data over time so that we understand what came in when, and we can go back and understand how it's changed over time. And then again, secure it, and finally layer this additional API control layer on top of the data so that these consumers on the right don't break every time we change our data lake. Okay, so let's talk about how to get from the lake up into this higher layer of value add in a hub. I'm just going to zip through this and say I have a metaphor very strong in my mind. I found a picture where there's these three layers and they're sort of floating on each other. The very top is the creme, or the creme de la creme on top. That's the highest value data where we have added some smarts, some harmonization, and some security rules and useful things to the data to make it consumable. In the middle is sort of a richer layer, which is a governed portion of the data lake where it's not completely ad hoc. And then down at the bottom, you might have your data science area, analytics, playground, where people can do all kinds of things with almost no constraints. So adding this foam on top is what I'm going to talk about. How do we do that? The deswamping guide, right? How do we get the value? First is within the lake, have some governance that doesn't try to lock down the entire lake, because people do need to copy files around in a very ad hoc manner and add new processes and play around with it, but have some section that's governed and another section that's more of a playground. And then, at a minimum, pull up some metadata, running batch processes to just do inventories and pull up metadata about what's in the lake. And that's good in and of itself, to build a metadata hub on top of the lake. But what's even a little better is to actually pull the data itself up into a more managed index format. Once the raw data, or some subset of it, is pulled up into an index format, we can then search it and aggregate it and check on it. Okay? So to do that, we transform it into a common format. And that's this term of harmonized data. At least some of it is maybe just 10, 20, 30 fields is common. So if I'm dealing with people, I might harmonize the names, addresses, social security numbers, employee IDs, mailing preferences, a few things like that that's central to my business. But a whole lot of other data about their order history and everything else I might leave as is in the raw format. And that's this extraction of the high-value searchable data. Finally, we want to secure it. Not finally, but critically, we want to secure it. And then access it via APIs. So there's some APIs to access it in a rigorous way. As a little note, we might leave this playground in the right-hand side of the Hadoop data lake. We might leave the playground unsecured, because there, in order to make these connections among things that you don't expect to be connected, people really do need access to all of it. But not everybody, right? You want a small group of highly privileged, highly trusted people who have gone through appropriate training programs about handling of sensitive data. Those people can access the unstructured playground. And there we go. Now we've deswampified, we've got the nice, clear, beautiful lake, and this cute kid swimming around in it, having a great time. So to sum up the difference between the lake and hub patterns, they're both patterns. Data lake is a very flexible pattern. The key is movement and flexibility, ad hoc operations. It's great for staging, it's great for batch, it's great for ETL, and then delivery to a downstream system that might really realize the value of the data. And it's partially governed, but it takes an act of will to govern a data lake or even part of it. And this is fundamentally a technology to see the business. Usually not in real time, but within a day or so, have reports and aggregates and insights into the business, or the enterprise, it could be a government agency or a nonprofit. But how am I doing? What are my customers and my suppliers and my regulated entities and my financial transactions? What's happening? So it's kind of a reporting function, see the business. Hubs, they're naturally governed. Usually it's going to be a NoSQL database I would, of course, recommend you use MarkLogic, and I'm going to tell you why MarkLogic is so great at this a little later. Some kind of NoSQL database that has an ability to at least understand and enforce schema if you want. It has the ability to put things through rigorous processing steps, the ability to track things over time and do quality control. Hubs are secure, at least the MarkLogic hub is. There are other technologies that are not secure that you could use. I wouldn't recommend it. And it has an API control layer to manage change for the consumers of the data. It's queryable, it's real time. So this queryable real time is a fundamental distinction. By putting things into this frothy layer on top, this hub layer, we're taking the data lake and exposing it in a microservices or service-oriented way. For example, a lot of people will do something as simple as running their batch mailing jobs. They might have a extracted key person data into the hub. They're managing it. Somebody might have 6 different records, but they figure out which one is the most recent, the most reliable, and they say, by gum, that's their mailing address. Then when they run a big mailing job of 1 million pieces of mail, they just hit that service in real time and say, what's John's address? What's Sally's address? What's Kumar's address? And that's a real-time REST API query, which a data lake, being batch-oriented, is not generally capable of doing. So that's for running the business. A little different than downstream reporting. You can also do downstream reporting once you enrich your data lake in this way. So this is a little metaphor, why science teachers should not be given playground duty. And I guess scientist Bob is about to whack this kid into the other kids to see how much they bounce around. And by the same token, you don't want your data scientists, who do need the unstructured access and maybe shoot from the hip a little bit, you don't want them to dictate your enterprise data strategy. There has to be somebody who's more of a data steward, who has data policy and data controls, overseeing the data lake and adding these critical things. Like I said, indexing the data, harmonizing the data, at least partially, and securing the data. Okay, so MarkLogic, where do we come into this pattern? Why are we better at this than other people, and what are my experiences as a person on the delivery side with actually doing this, right? So MarkLogic's a NoSQL database. We're the preeminent enterprise NoSQL database, so if you are sort of doing grown-up data functions, MarkLogic is probably the right database for you. We embed transforms and a depth of experience. We were NoSQL before NoSQL existed. We predate the term NoSQL, but we are a NoSQL database. Our formats and processing technologies span what we call multi-models, XML model, JSON model, the RDF model for semantic data. We have full text indexing built in, and the SQL model for read. We project data out into SQL views. We also have something specific to this task called the Data Hub Framework. I'm actually going to use that tool with some screenshots to illustrate this process a little later. That's an open source tool using MarkLogic to gather data and pull it up into this top tier of Hadoop. I would say we're not a Hadoop technology, but we run in the Hadoop ecosystem, and we've become this top tier of the Hadoop data lake. Massively parallel, elastic in the cloud. We can grow and shrink in the cloud and do all those things. And we're in all the, which industries? Sort of all of them, healthcare, finance. I tend to do a lot of human services and healthcare work. I used to do more intelligence and defense work. And we have a lot of customers, and they have a lot of logos, so they're there. Okay, some use cases that I've done myself, and I think we're doing okay on time, so I'll just take a couple minutes on each of these. I was working with a large government customer, U.S. government, and I do like the normal data lake pattern, but I will say that we were building the main transactional system with them and for them, and another contractor with another set of technology was building a data lake to take that transactional data and analyze it as a lake. We didn't think that was a great idea, but they wanted to do that. But this is not a case where we're pulling data up out of the lake. This is actually a case where we're the front end, we MarkLogic, are the front end transactional system feeding the lake. And what they had to do was switch a lot of their reporting over to MarkLogic, because our transactional system naturally also has an analytical capability, and it took them 18 months to get the data lake straightened out. The rate of change, the ability to take all of this message data that we were dealing with and turn it into tabular data suitable for mostly Hive and Informatica processing. It was just too high of a lift, and we were tracking all the historic records. Keeping the historic records and the current records sorted out was too hard in that technology paradigm. Another project was I think it was PeopleSoft replacement. EAP might not be the right term here, actually. A PeopleSoft replacement. They were moving from one massive enterprise system to another, but they had built so many ingests and exports from that central HR system that they couldn't remove it. So what we did was we built them a system to pull in all the raw data that was coming in from the imports and put them into one of these data hubs, and then pretend we were PeopleSoft and push out all that data to hundreds of downstream consumers. So a vast amount of data prep and data munging and data delivery. And what that allowed them to do was then switch over to this new system but not have all the old systems break. So we handled 300 data feeds in a very short time, including these things that are critical, right? The ability to query the data, secure it so only the right people can see the right data, and have APIs that match the APIs of the existing consumers. And then finally, this is more recent. I've been working on a customer 360 project for a big company, and they're doing much more of the traditional data lake cleansing operation. They have a policy that all data goes into the data lake. All data streams go into the data lake is the metaphor, right? And then they would use that data lake to partially or completely prepare some more harmonized data and send it into the data hub. Once they got into the data hub, they would then have real-time access. And this is actually one of the customers that is doing batch mailings. They're also supporting their users who log in and just need to see their data, so their web app is directly hitting the data hub so they can see the latest consolidated data to support the customers. All very successful projects. And I'm happy to answer more questions about these in the question time. So think about or type in questions, and we'll talk about them soon. We'll actually take a minute, preview the Q&A here. There's some questions about data semantics. And masking. Okay, so just getting a quick view of what people are asking about. So the Data Hub Framework is a tool that helps do this. It provides fast time to hub. It automates a lot of the process. It has GUIs to help the developers. It generates code scaffolding. It's standards compliant. It just makes HTTP services and SQL views. And it's integrated with Hadoop. So I'm going to use that to illustrate a lot of things in the second half of this presentation. So let's look at this process of taking the ungoverned loop, making it governed. And let me just see if I have another slide now. The animations didn't work on this, but that's okay. So the things that I'm going to talk about. So I'm going to talk about inputting the raw data, taking this governed section of the data lake, and inputting that up into the raw data section of the data hub on top. I'm going to talk about building a target model progressively, just a little bit at a time, generating code templates. That's pretty low-level stuff. We're not going to get into code here, but I'll just show that briefly. And then running those code templates to get the harmonized data built, and then securing and serving up that data to the consumers. And then that then on the top in the hub is this controlled, secured, versioned data in a common format with real-time access. Very different than the playground where there's a bunch of data scientists running, batch jobs or pulling it into Spark or something, trying to do machine learning. Okay, so the first thing is the Data Hub Framework for this first step here, the ingesting it up into the raw data area. There's a thing called an input flow, and here's the GUI of the Data Hub Framework tool, and you hit a button that's off the bottom of the screen, and it starts a job, and then that job completes, and you can see your job. Once it completes, what it's done is it's taken the raw, in this case it's CSV data, and it's done a trivial transformation of that into JSON. So this is really the raw data. Every field See the empty description on line 5 of the input? It remembers that there was an empty description. The title, the SKU, every piece of data is called what it was called and tracked in exactly its raw format. Then the data is harmonized. Now to do that, we have to first say harmonized to what? So there's a little data modeler, and this is something that's core to MarkLogic. We have an entity model. It's based on Swagger, which is a JSON standard for a data model. And you can do a little modeling and say, here are the 10 or 20 or 50 or 500 fields that I think are the most important that I really want to harmonize into. Again, progressively. Start with 10, start with 20, get a few business cases out. You don't have to wait to pull in all of your data, but you want to harmonize a little bit. And that's going to generate this code template. You can see this little section, var, var, var. This is just where do I go in that raw data to get these critical things. And then you can run this. This code is executable as what's called a harmonized flow. The harmonized flow does all these cool things. It checks, well, they're all optional. You can check on the quality. You can check it against the schema to see if it conforms to an incoming or outgoing schema. You can join data together to get one master 360-degree record. You can track the versions and the historical versions over time. And of course, perhaps most importantly, you can secure the data. And again, this model generates a template. This template isn't the template to make the main data. This is the template to just put some headers on it. So this is the metadata extraction step, and this is the no-op. This is just returning empty. And then people go in there and they say, okay, I'm really interested in tracking certain kinds of metadata. When was this batch run? Who authorized this? Were there any data conflicts? You know, adding metadata. Once that's done, the data is going to look like this. This is called the envelope pattern. Again, low-level stuff. I'm going to come up to a higher level very soon. The envelope pattern has an overall envelope. You see the first line of the JSON here is envelope. And then the raw data goes down here as the so-called attachment. You can keep all of it or some of it. That's completely non-transformed. So you don't have to transform anything. You're keeping your data as is. But you do a little bit of a transform to get those 3 vars off, right? The three key fields, extract some headers, in this case none, and extract some triples. Triples is the RDF semantic data, where you can use OWL and semantics and make sure that the data really has meaning. So all of those things have a different little, called a plugin, where you write a little script to take care of it. If you write all those little plugins, you'll be able to do all this stuff. So that's, let me put this back in the phrase of, of the data hub pattern. So this is, the first phase was to bring it in raw. The next phase is to model it and put it into a common format like this, but progressively common. Over time, more and more of the data in the attachments area will move up into the instance area. But get a handle on the data, and then pull out some metadata. Once that's going to be done, if you recall the next steps, we're going to secure it and expose it. So the next thing is to secure the data. This is a MarkLogic certificate-based security screen, so you can secure things with HTTPS and FIPS 140 encryption and encryption on disk and two-way certs and all that stuff. Then you can do role-based security for every record so that you know exactly which users and which accounts and which subsystems have access to which data. So I work on healthcare.gov a lot. One of the things we do is make a distinction between the regular data, which includes PII, personal identifying information, and FTI, federal tax information. The federal tax information is governed by the IRS security rules, which are much more strong. So we put them in different security realms in the database. And this is how we assign different roles. And then finally, you can look at the pathways. This is a kind of dense format, but that's XPath, and you can use that on XML or JSON records. That's the path to which field might be either encrypted differently or redacted on extract. So you can say, I want this entire record to be medium security, but I want the social security number to be high security. Or I want to pull this person record, but I want to redact their phone number so that I can get a safe view for a certain kind of user, but then a different kind of user can see the whole record. Okay, so we're putting security on top of the data. Notice it was very important to harmonize the data, because if we don't have it in a common structure, we can't apply a common security regime. Okay, the last thing here is to expose it. So here's a REST API call. This is the MarkLogic REST API, where once the data is in there, you apply APIs. Again, if you do this with a different technology like data stacks or Dynamo or something, you could do it, but you're going to have to build, some kind of an ESB layer or camel routes or other things on top of that tool. MarkLogic kind of does it all in one, so we're a little more mature, but the pattern still holds if you use a bunch of other technologies. So this is extracting an API showing people. That's if you harmonize the data into people forms. And that's really important. This is showing it in a browser, but this is really an enterprise communication mechanism so that you have controlled, defined contracts for how to access data in real time in the enterprise. So important. I was talking to the Veterans Administration. They have 14 different business units. Any one of those could capture the fact that somebody is deceased. Any one of those could have an address change. Any one of those could have some information about what kind of benefit someone is eligible for. But if you can't get it all into one place, you can't make a simple web service call and show it to the veteran. You can't make a simple web service call and show it to the veteran's doctor. So you want to expose this in real time. This is a SQL view on the same data. Again, that's something that MarkLogic does out of the box. You can write a little mapping called a template, and that mapping will push the data into a SQL view. If you do it with other technologies, you would have to build ETL jobs, but you could do it. Okay, so in summary, we've got the data lake pattern, and then the extension of that, which is the data hub pattern. Data lake is, let me see if back up. Data lakes are focused on moving the data to one place, and people struggle to get the value out of it, honestly. I think I said made the metaphor, if you tell your kid their room is a disaster and there's crap all over the floor, junk all over the floor, clean your room, and they take all the junk off the floor and they throw it in the closet and close the door, did they really clean their room? The room looks clean, but the junk is still junk. It's not organized, right? So data lakes mostly just move it and batch process it. And you can use that to see the business and report on the business, but not interact with it. Usually this is Hadoop. The data hub pattern is different. It's for running the business. Put it into usable forms and then actually use it in real time through REST APIs and batch exports and SQL views. Govern it, secure it, understand what the data is and who's allowed to see it, and route people through this channel, the data hub channel, so that they get secure, minimal access views on the data. For those high-powered data scientists, give them access to the entire data lake, let them go spelunking around and read anything they want, but that should be the exception, not the rule. And this is really a NoSQL pattern. The reason it's NoSQL is that when you're pulling things into a data lake, you're pulling things in from all kinds of different sources in all kinds of different formats. Message traffic, standard exports, XML, relational data import, maybe RDF semantic data, graph data, image data, PDFs, Word documents. You're pulling all this stuff in. All those things I mentioned are handled natively by MarkLogic, and many of them can be handled more easily by a NoSQL system in general. I'm trying to be nice to other NoSQL systems. The truth is I don't think they're very mature. I don't think they're ready for prime time, and I don't think they handle enough data formats. I think MarkLogic does, and you should look seriously at MarkLogic. So we handle all those kinds of data natively, and that way anything that you can put into HDFS, you can pull it up into the data hub in MarkLogic without having to write some big processing layer. So this arrow from the governed area up becomes very easy with MarkLogic. And then the value add there is indexing it, harmonizing it into a common form, and exposing it with controlled APIs. So these are complementary patterns. They do the two different purposes, right? The data science, see the business function, and then that feeds naturally into the data hub, which lets you run the business. Here's a bunch of other resources that you can look at when you get the PDF of these slides, which you'll be able to see pretty soon. Here's a blog post on how to regroup after Hadoop. Here is a blog post by me on data hubs, data lakes, and virtual databases and how they differ and how to decide which one to use. Here are slides on the Data Hub framework. A great way to get into the Data Hub pattern is to take 30 to 45 minutes, maybe an hour, go through the Data Hub tutorial. It's a quick download, quick install, and it just takes you through these steps with some sample data. And then look at some videos at MarkLogic University. These are 3 or 4 10 to 15-minute videos that talk about data hubs. So with that, I'll move on, bring this picture of the pattern up again, and answer questions. The first question people may ask is, what's this wonderful statue? This is actually Michelangelo's statue, The Thinker. So everybody knows Rodin had a thinker statue, but it turns out Michelangelo did as well, and here it is. With that, I'll take a look. I'll hand it back over to Mike and Diane, who's on the line and can sift through these questions. Or I can just take a look at them myself. Does anybody have any sorting of the questions that I should go through in any order in particular? I'm just going to jump right in that. So the first question I have is, how does the model presented scale to projects and companies with lower, how does it scale down to lower volume data, the complex mixes of types, smaller, more compact companies doing geoscience? I'll throw in there that MarkLogic handles geospatial data natively, so a little plug for MarkLogic. We have really great geo. There's 3 or 4 dimensions to so-called big data. One of them is volume. You just have a lot of data. Well, that's big data. I've worked on systems with 100 terabytes of data, and if you put off a bad query, you have to kill the system. You just can't ever finish the query. But the other dimension is variety. If you have highly variable or deeply nested complex data, you really want to manage that as documents, XML or JSON documents, almost all the time. If you try to deal with very complicated things as relational data, the modeling and mapping takes over the entire project. So let's say I have, we work in the financial space, FixML, fixed income exchange instruments in the financial space, very complicated and very varied. And they change so quickly because of innovation that you can't keep up with the relational model. So we deal with them in their XML format directly. And then what you do is you do the same thing. Let me go to my slides and go back to the right one here. You harmonize it, right? You want to progressively take the 30 or 40 fields out of 800 fixed geotechnical fields and make those standardized so that you can search them, aggregate on them, analyze them, correlate them, do linear regressions on them, do all the good stuff on that high-value data, or just search for it and show it to the user in a really nice GUI. But then you still have the rest of the data as raw data where you can drill in and see the raw record. But I hope that answers the question. And I don't know if people can talk and say if it answers their question or not. Another question here, is it reasonable, and if people could talk, I would love to hear people. I don't know if that can be done with this technology, the On24 tool. Is it a reasonable approach to take progressive organization, like the growth of a crystal, as you try to seek to gain control? I love that metaphor of the growth of a crystal. Yeah, progressive harmonization is progressive organization. First thing is just bring all the data into the not the playground, into a governed place where you know what's there, and index it. Once it's indexed, you can then query out the parts that are most important and just harmonize or organize, again, 10, 20, 200 fields that are absolutely critical, and then expose those as APIs to various consumers. What tends to happen then is people will go, oh my goodness, that was great. And in just a few months, they stood up this wonderful thing. I want my data in there. Now you say, okay, what do you need it for? Well, I need to do something a little different. I need the geo coordinates and the work history. Okay, let's model another 30 or 40 fields around geolocation and work history. And then that slowly expands the progressively organized part, which is very much like crystals growing. I hope that answers that question. What's the most useful way to communicate to business stakeholders about how the data is organized and indexed? Hierarchical versus sets and tags. I would say that the business stakeholder should really look at the APIs that are provided and then go do their work and mind their business. The business stakeholder should not be sniffing around down in the data lake trying to figure out what's going on. If they are, you've probably done something wrong with the data lake. Because that's the idea of this API control. The API is the contract between the consumer and the data lake team. And the data hub pattern allows you to provide things with APIs and control the APIs. MarkLogic provides schema on read. So you can have version 1 of the harmonized data, right? Your crystal is starting to grow. You got version 1, which is sort of this minimal person data, right? Then a month or two later, you put out version 2, but you put a transform in place so that the new version 2 record can still be exposed as version 1. So nobody using version 1 breaks. That's pretty classic problem in API management, to have the old version of the API stay up and running, and then the new version comes out, and you publish it, and you say to the business people, hey, there's a new version of this API. You can use it. And by the way, we'd like your input on what should be in version 3. But I'd stick with that API when talking to the business users, and they shouldn't be breaking encapsulation to link themselves in any way to what's actually happening in the hub. Another question here, what's the difference function with governed and playgrounds? I'm not sure I think the question is, how do you decide what goes in the playground and what becomes governed? And I think that's also likely to be a progressive, or what did somebody just call it? A progressive organization process, right? Progressively organize what part stays governed. So certain batch loads have to be brought under control, meaning the team that does those inputs to the lake have to know that people are relying on them not to change their formats willy-nilly. Other areas can be copied and recopied and changed in a much more flexible way, but nobody should really be relying on those other than the small teams that are using them. So I hope that helps. It's unfortunately harder in the data lake itself, in the Hadoop ecosystem, to enforce governance of a certain set of data. It just has to be done through process rather than technology. Another question. Can you give an example of a company successfully deploying useful data models piece by piece, and how we can do this without breaking the APIs that run the business? Let me think of who's referenceable for MarkLogic. I worked with the county that I'm sitting in right now, Fairfax, Virginia, and we gathered a lot of their data, everything from how land is being zoned, what buildings are being built, what permits are being issued, what complaints are being issued, what watersheds have various kinds of drainage control in them, and the water quality in those areas. We started to pull in a lot of their data, and we enabled certain kinds of searches first, right? The first searches were, I want to see the permits that are happening in my area, and I want to see the complaints in my area. That's for a citizen to just know what's happening within a few blocks of them. And we had geospatial enabling so they could outline their neighborhood and search inside of it. And over time, we would add more and more data to it. We'd say, okay, I want to, now maybe for the business community, they have a new API. They want to see the proffers and the bonds being issued and the zoning being done for their major developments. And then we added that data. And so every few months, more features would appear on the GUI, or more features would appear as an internal data set. That's one. Another one is a big insurance company that I don't think I can name, but it's an insurance company you would know, a really big one. And they pulled together their pharmacy claims data, their medical claim data, their dental claim data into one consolidated system. Then they layered on top of that other data about insurance, such as the insurance policies. Somebody could go in and see their claims, but then they could also link that to the policy, the insurance policy that was allowing that claim. And they just grew the data over time. So again, internal and external consumers. Some shopping system needed a lot about policies. So in phase 2, we added that. Phase 1, it was about the consumer. So we put more of their claims and their basic demographics. I hope that helps. And the APIs were controlled, right? The initial API, let me see my claims, didn't break when we added, here's the policies. It grew. Version 1.2 went out, which now had an annotation on every claim as to which policy enabled it. but it didn't break. The old API was still in existence, and the new fancier API was available for that development team to incorporate in their next release. What's MarkLogic's view on GDPR, which is the European Union's General Data Protection Regulation, which says you must allow a right to forget, okay? So how do you use this remembering technology to forget? One thing that people are doing with MarkLogic is they're pulling in a lot of data, they're putting it into this raw data repository. MarkLogic, unlike Hadoop, indexes it very heavily. We do very aggressive indexing, and then you can search for Social Security numbers and phone numbers and things that indicate that there's personal data. And what that allows you to do is you can pull in 50 sources, each one of which has 300 tables, and then start searching around to find the personal data, right? Because until you get a handle on it, you don't even know where the personal data is. And that is a way of assisting in organizing what data is there. And when Sally Jones comes in and says, I need to be forgotten, you can find her records in all these systems and do a single search across all of them. And then you have to, well, you don't have to, but what they're doing right now, they're not automating it, they're not doing write back, they're sending that message to all those system owners to say, hey, here's a ticket, you got to forget Sally Jones. And then the data hub remembers the fact that we forgot Sally Jones. Because once you've erased her from the source systems, now there's no record of her even being erased. So there needs to be another place that tracks who's been forgotten. So it is very useful because pulling all the data into one place is obviously much easier to manage things than to try to have 50 systems with 50 different right to forget processes. If you lose the link to the SSN PII, is that the same as forgetting? I don't think so. I think that if you have an SSN somewhere, that still has the knowledge that that person, maybe I'm a drug rehab center and I've got somebody's social in one of my records. Well, that means that they were doing something with drug rehab, and that's very sensitive, right? So I think you really do need to forget. Here's a question about healthcare data, which gets into the weeds in a lot of directions, the questioner, Ash, is saying. How do you progressively organize data and make it usable early? Yeah, this really all goes to that progressive organization, right? Pull it all in, and you're immediately, especially with MarkLogic, because we index everything, you're immediately able to query and visualize your data and see what's there if you don't fully understand what's there. And then using it early is this progressive harmonization. Build a very small model and initially just map data fields with those transforms into this very small model. You can do that very quickly, get something up and running in weeks or months instead of years, and have a running system. You've still got all of the old data that you haven't really dealt with yet. I like to say, you want to be a data marine, right? The Marines say, leave no man behind. When you're moving your data, leave no data behind. A real limitation of relational systems is you have to model every single column before you can copy it into the relational system. With a NoSQL system and with MarkLogic, you can copy the data in as is, and you can have it and store it and keep it. And with Hadoop HDFS, you can just put it on the HDFS file system and have it, and then use it as time allows. How are data semantics preserved during ingestion? It seems that lakes would generally tend towards distributed business logic and data semantics. I'm not sure if this exactly answers the question. This is from Scott. But one very important thing that we focus on at MarkLogic is lineage of data. So one operational semantic for data is where did it come from and when did it come in? If something came from the field pers underscore ADDR underscore C2, right? What is C2? It could be that nobody remembers except for some guy who retired last year what pers underscore C2 is. But by tracing it back and having the raw data with that exact field name and then a link from the harmonized data back to the raw data, you're implicitly linking all the way back to the source system, which hopefully has a data dictionary. In addition to that, you can annotate your entity models with various annotations. And we actually store these entity models in the core database. So you can query the data and you can query the semantic model at the same time and answer sophisticated questions like that. That's a little bit of a pro move, right? To start to build systems where you're managing the definition of the data and the data together and linking them. We do that. It's not a very common thing to do, but it is the holy grail of really understanding your data. And I hope that answers the question. Hadoop is very bad at that. With Hadoop, you run some pig job. Actually, they have things called pig, hive, whatever. And you create some new split, and nobody knows what came from where, or what was changed, or what was cleaned or deduplicated, or what happened to it. And what happened in the customers I've seen is they have this data, but they run a report on it and they don't believe it. They don't think that the data is clean. They say, yeah, well, that's a nice number, but how'd you get to that number? Did you drop some duplicate records? Did you do it? Did you filter something out? Did you aggregate something together? So the traceability really allows you to at least find the semantics when you need it. Is this ELT instead of ETL? Yes, it is. So ETL is a standard term meaning extract, and then transform, and then load. And you have to do that with relational. Like I said a minute ago, you can't load into relational at all until you transform it into the format that the relational system wants. So you have to do ET and then L. With flexible technologies like Hadoop and MarkLogic, you can do EL, extract it and load it as is. You don't even know what it is, and at least you've got it, right? You've moved it. It might not be indexed or normalized or harmonized. And then you can transform it later. And you can transform it progressively, bit by bit, like a crystal growing. Love that crystal idea. So this is definitely ELT in its fundamental nature. At what stage is it advisable to overlay masking, and what form does this take? You want to overlay masking after you have harmonized and indexed the data, because once you've masked it, if you don't already have it indexed, then it's too late, right? So you got to get it into a common form. You can't even specify what to mask very easily if you don't harmonize it a little bit. If you've got 50 systems coming in from 50 different data silos and you want to mask the social, you've got to keep track of where the social is in all 50. But if you have those 50 systems and they all have some person data and you put them into one person format, now you can just say, okay, person.identifier.ssn, I want to mask it. And your ability to govern and control and mask the data, and like I say, MarkLogic has built-in masking, is much easier. And you want to mask it on the way out. You don't want to mask it before you index it, because then for those people who do have the high security privileges, the high security role, they're going to need to see and query on the social. So I'll go to my slide and show the phase of that a little further ahead, I think. Boy, I got a lot of slides, huh? There it is. So this delivery phase, where the REST API or the SQL are going to pull data out, we have a technology to say, I want the social to be masked, and for any of these views, automatically and instantaneously, it will not always be masked. If you call the masking API, it'll apply the mask and give you the data. If you have admin to the database, you can still see it. That's where we do the masking, and that's where I would recommend doing the masking. With that, it's a minute left. So I think I'm not sure if anybody has any wrap-up questions or anything else that they want to ask or say. But with that, I'll let people have 30 seconds back in their busy lives, and I just want to express my appreciation for people being here. It's a pleasure to talk to everybody and go through this stuff, and I hope it was useful. Thank you.
Okay, a big thank you to Damon and the team at MarkLogic, and thank you to everyone for attending this online presentation, Cleaning Up Your Enterprise Data Architecture, How to Make Your Data Lake More Effective with an Operational Data Hub. We hope you've benefited from this presentation, and we hope to see you all on other O'Reilly online trainings in the future. Thanks again, everyone, and enjoy the rest of your day.